Hello, thank you for joining us. In this presentation, we will walk you through the process of deploying a Windows Server 2019 virtual machine in Microsoft Azure, enabling Hyper-V, and configuring server roles such as Active Directory and DNS. This project demonstrates both technical proficiency and practical application of cloud-based infrastructure tools. Let's begin with the initial step, acquiring the server image. The foundation of any server deployment is selecting the appropriate operating system. As a team, we chose Windows Server 2019. It's a robust enterprise-grade OS that's widely used for data centers, virtualization, and domain-based network management. To get a copy, we used Microsoft's Evaluation Center, which provides a free 180-day trial ISO for evaluation and learning. The interface is straightforward, and as shown in the screenshot, the ISO can be downloaded by selecting the desired experience. Although we deployed in Azure and used a pre-built image, this ISO is important for on-premises or hybrid scenarios, where you may need to manually install the OS on a physical hardware or a local hypervisor like Hyper-V or VMware. Next, we moved into Azure to provision the virtual machine. Azure is Microsoft's cloud platform that allows infrastructure as a service provisioning, also known as IaaS. We signed in via the Azure portal and navigated to the virtual machines service. Screenshot, you can see the Basics tab, where we specified the resource group, CYB300T4, and assigned a machine name, CYB300-SR01. We also chose a region close to our location, which improves latency and access speeds. This tab ensures that all your resources are logically grouped and made for easier management. Once the VM basics were defined, we configured more advanced parameters. We chose Windows Server 2019 Data Center Gen 2 image, selected the x64 architecture, and opted for a VM size that offers 4 virtual CPUs and 16 gigabytes of RAM, sufficient for running server roles like ADDS and Hyper-V. We also defined the administrative credentials for role-in and configured inbound port roles. For RDP, port 389 was enabled to allow remote access. Azure also offers flexibility here. You can apply network security groups, or NSGs as they're known, to tightly control access, especially in production. Before deploying, Azure provides a Review plus Create summary screen. This step is crucial because it validates the configuration and identifies errors or warnings. Here we confirmed those selected settings: region, OS image, networking options, and access rules. Once everything passed validation, we clicked Create to deploy the VM. Azure then automatically handles the provisioning, networking, disk replication, and virtual NIC setup. After a few minutes, our deployment was complete. Azure displays this confirmation screen with quick links to monitor performance, set auto shutdown, and access the resource. This step confirmed the VM was running, had a public IP assigned, and was ready to accept connections. To manage the server, we connected using Remote Desktop Protocol, also known as RDP. We downloaded the RDP file from the Azure VM's Connect tab, which contains the public IP and port settings. After entering our credentials, we gained full internet access to the server, similar to working on a local machine. This connection method is especially helpful for GUI-based tasks like server manager configuration, PowerShell access, and role installation. Once connected to the server, the next step was to enable Hyper-V. Hyper-V is Microsoft's virtualization platform and allows us to run additional virtual machines inside our VM, known as nested virtualization. This is only possible and supported Azure VM sizes and OS configurations. To enable it, we launched PowerShell as an administrator and use the following command you see on the screen. This command installs the Hyper-V role along with the management tools like Hyper-V Manager. The server automatically restarts to complete the installation. The screenshot shows a successful execution of the PowerShell command with a restart prompt. From here, we can launch Hyper-V Manager or use PowerShell to create and manage VMs within the host. This setup can support nested VMs for development, sandboxing, or training labs, all without needing physical infrastructure. The next phase was configuring key settings within Server Manager. We renamed the computer to CYB300-SRB01 and joined the workgroup Cyber Team. We also confirmed that Windows Defender was enabled, remote management and remote desktop were active, and NIC teaming was disabled, since we are using a single virtual NIC. All of these steps help harden the server and prepare it for adding rules and services. They also ensure the server can be accessed securely and managed remotely. We then configure the network settings manually. Using the network properties, we assigned a static IP address, 192.168.100, with a gateway of 192.168.1.1. For DNS, we use the same IP to allow the server to resolve itself once it hosts the DNS role. We also added Google's 8.8.8.8 as a secondary resolver. Static addressing is critical for servers, especially those hosting Active Directory and DNS, because DHCP can cause unexpected address changes that break dependencies. Once the network was stable, we moved on to adding server roles. Using the Add Roles and Features wizard in Server Manager, we installed Active Directory Domain Services, which is used to create and manage domains, users, and policies, DNS Server to resolve domain names internally, and File and Storage Services to manage shared storage and folders. These roles form the backbone of most enterprise server infrastructures. The wizard guides you through the selections and shows dependency checks before confirming installation. In the final step, we validated all changes. The Server Manager now shows the server name, workgroup, active roles, and memory usage. The ADDS and DNS services were installed and waiting for domain configuration. This confirms the server is fully configured and ready for enterprise use or continued lab development. In conclusion, this project involved hands-on experience in building a Windows Server environment using Microsoft Azure. We walked through the OS selection, VM deployment, Hyper-V setup, and full role configuration. Thank you.